All right, everyone, we are moving on to fractions very soon. And before we begin actually doing fraction math, we're going to spend a little bit of time preparing for what we need to know in order to make fractions easier. So today we're going to look at some divisibility rules. And a divisibility rule is simply a mental math trick that we can use to help us quickly decide if a larger number can be divided by a smaller number. And this is going to help us tremendously when we are trying to find common denominators, write equivalent fractions, and simplify fractions. So memorizing these rules is going to make a lot of the math we do in the future much easier. So we're going to jump right in, and we're going to look at the most common numbers that we're going to be dividing into our larger numbers when we're dealing with fractions. So we're going to begin with the divisibility rule for the number 2. So it's really important that you fill out your notes neatly when we're doing this, and very legibly, because this list is going to be really helpful for us as we're working. So 2 has an easy divisibility rule. We simply have to look at the number, and if the last digit of the number is even, the whole number is divisible by 2. So we have some examples over here, and we're going to look at the 7 and the 8 in these numbers. So the larger number, 237, we can quickly decide if that is divisible by 2 by simply looking at the 7 in that larger number. And 7 is not even, so not divisible by 2. And then I'm going to now look at the larger number, 578. Simply by looking at the last digit, the 8, I can see that it is even, so 278 is divisible by 2. So the divisibility rule for 2 is really simple. Straightforward, just look at the number and check out that last digit and see if it is even or not. All right, so we're going to move on to the next divisibility rule, which is the rule for 3. The divisibility rule for 3 isn't quite as straightforward as the rule for 2, but it's also not hard. So if you memorize this rule, it's going to make it very easy to quickly decide if a large number is divisible by 3. So we're going to use this trick. We add all the digits in the number. If the sum of those digits is divisible by 3, then the whole number, the larger number, is also divisible by 3. So the example that we have is the number 234. So I'm going to add each one of those digits up, and I'm going to say 2 plus 3 plus 4. So when I add those up, I get 9. And I know that 9 is divisible by 3. So that means I can evenly divide 234 by 3. So it's kind of a cool trick to use. I'm going to show a couple other examples on the back of my paper. You don't need to write these down, but just pay attention as we're going over them. So we used that trick and we said 234 was divisible by 3. And we're just going to go ahead and prove that. So I'm going to say 3 goes into 2. It doesn't. So 3 goes into 23. So we're going to say 6 times 3 is 18. That gets us pretty close. 7 times 3 is 21. That gets us even closer. So let's use 7. 7 times 3 is 21. And 3 minus 1 is 2. 4. 8 times 3 is 24. And we can see that 234 3 goes into 234 exactly 78 times. But if I simply change this and I use, like, let's say the number 241, we can do our trick first. So 2 plus 4 plus 1 is 4, 5, 6, 7. 7 is not divisible by 3, so 241 is not going to be divisible by 3 either. 3 goes into 24 8 times. 8 times 3 is 24. Bring down my 1. 0 times, does 3 go into 1? 0 times 3 is 0, with a remainder of 1. So I end up with a remainder. So that trick is going to work for us. Without doing that long division, I would have been able to quickly determine what 3 will go into and what it won't. So it's a pretty handy trick. All right, let's go ahead and look at the next divisibility rule for 4. If you divide the number by 2 and it is still an even number, then it's divisible by 4. So that simply means I have to start with an even number. If the number isn't even to start with, this isn't going to work. So I can look and say, okay, is the number even? And if I say yes, then I can divide it by 2. And then I look at what my result is of that. What is the quotient after I have divided it by 2? If it's still an even number after I've done that first division, the whole thing is also divisible by 4. So I'm going to use 24 as my example. 24 divided by 2 is 12. 12 is still an even number. So that means I can divide 24 by 4. And that works no matter how large the number is. All right, the divisibility rule for 5 is another great one because it's simply a look and see. So if I want to know a number is even by 5, I look at the last digit. If the last digit is a 0 or a 5, then the whole thing is divisible by 5. So my 2 examples, I have 140. It's a 0. That's one of my numbers. So yes, it's divisible by 5. To 11, it's not a 0 or a 5, so not divisible by 5. All right. So the great thing about the rule for 6 is that the work is already done for me. Because 6 is a number that follows the rules of 2 other numbers that we've already done. So I ask myself, if it follows the rule for 2 and for 3, then it's also going to work for 6. But it must follow both of the rules. So it must be an even number. So that's the first thing you can check. If it's not even, it's automatically not divisible by 6. If it is even, I can move on and check the second rule where I add the digits together. And if the digits are divisible, the sum of the digits is divisible by 3, then the whole thing is divisible by 3. So if I've said yes to 2 and yes to 3, then I know it's going to be divisible by 6. So 96 is my example, and it is even. So I can go ahead and look at the next rule. And 9 plus 6 is 15. 15 is divisible by 3. So this is yes to 2, yes to 3, which means yes, it is also divisible by 6. All right, we do not have a rule for 7. I know there are some rules out there that work, but I have never found one that's easier than just doing the long division problem. So we don't do a rule for 7. So we're going to move right on to 8. And for the rule for 8 is very similar to the rule for 4. If I can divide the number. In this case, we're going to look to see if the number starts as an even number. It has to start as an even number. And if we say yes, then we go ahead and we divide the whole thing by 2. And if it remains an even number, then we try to divide it by 2 again. And then if it's still an even number, we can divide it by 2 again. And that tells us we were able to divide it by 2 3 times. And that means the whole thing is divisible by 8. So I'm going to start with 96 divided by 2 is 48. 48 divided by 2 is 24. And 24 divided by 2 is 12. So every time my answer was still even, I can go ahead and say that this whole thing is divisible by 8. All right, moving on to 9. 9 is a rule that works very similarly to the 3 rule. So we're going to simply add the digits together, and if the sum of the digits is divisible by 9, the whole number is divisible by 9. So I have the number 198, And 1 plus 9 plus 8 is 18. 18 is divisible by 9. So the whole number 198 is also divisible by 9. And finally, we have the rule for 10. 10 is another one of those great ones that's just a look and see. So all we have to do is see if the number ends with a 0. And if the number ends with a 0, then it's divisible by 10. So the number 280 is divisible by 10 because it ends in a 0. And then the number 121 does not end in a 0, so it is not divisible by 10. All right, so we're going to use these rules to help us with a lot of our fraction work. Keep this list handy so as you are working, before you have them memorized, you can go back and check your work as you go.